All right, so in this section, we're going to try to find areas of other types of polygons. We've talked about areas of parallelograms and like rhombi and kites. We've talked about triangles. We've talked about circles, even though a circle isn't a polygon. Today we're talking about other types of polygons, okay? All right, so let's first remind ourselves what a regular polygon was. A regular polygon is a polygon that has all sides congruent and all angles congruent. Now, just like we've done in the past, when you have an irregular shape that you want to find the area of, what we do is we divide that shape into smaller shapes that we know the areas of. So for example, we can divide it into triangles, rectangles, trapezoids, right? And that's what we're going to do here. What shape is this? This is, how many sides does this have? A pentagon. Sorry, I couldn't hear. This is a pentagon, right? Now, I don't have a formula for the area of a pentagon, but what I can do to this is this. I can draw a segment from the center to each vertex. So if this is the center, I'm going to draw a segment to each of the vertices. Okay? When I do that, how much is this entire angle here that makes a circle? 360. And how many of those angles do I have? 5. So each of them will be how big? If you divide the 360 equally into 5, each of them are 72. Okay? So I have 5 triangles, right? And they're 72. Now, what do I know if I take this one triangle right here that I've put the star in? What type of triangle is that? That's an isosceles triangle, right? Because these are equal. Okay? So if you draw a segment from the center to each vertex, the triangles are all congruent and isosceles.
Is that for every polygon?
For every regular polygon. For every regular polygon. Okay? Now, the central angle then, how big is the central angle? Each of these central angles, 72. How did we find that? Well, we did 360 divided by the number of sides. Okay? That's important. 360 divided by the number of sides. Now, there is a special line that we can draw from the vertex of one triangle to the opposite side and perpendicular. So what is that? Is that what do we call that? Is it a median? Is it an altitude? Is it a bisector? What have I drawn here? That's an altitude, okay? That altitude has a special name, apothem, okay? Not apothem like apothecary, apothem, okay? The apothem is the segment drawn from the center of the polygon perpendicular to a side, okay? It's in this picture here. That's the apothem. And what would it divide that central angle into? 2 congruent angles. Okay? Now, how many triangles? So however many triangles we have here, right? All the triangles are congruent to each other. So if I wanted to find the area of this pentagon, what would I do? I would have to find the area of one triangle, multiply it by 5, and boom, I've got my area. Okay? Once I have this apothem, that's the height of that triangle. Okay? And that's the side. So I've got my half times base times height. All right, so let's go here. So what's the area of the regular polygon then? Okay, so let's do this. How much is the area of one triangle? Let's see. area of one triangle is equal to half times base times height, right? What's the base? This is the base, and that's the side of the polygon, right? Now, if we've got a regular polygon, okay, how do all the sides compare to each other? They're congruent to each other. All right. Now, if I have 5 of these, right, then what am I going to do? It's going to be, I'm going to multiply this by 5, right? And if I do, okay, so area of the entire is going to be half times, let's say, 5 times base times height, right? And what is this? 5 times one of the sides. How much is that? That's the perimeter. Do you see that? 5 times one of the sides, or 6 times one of the sides. I'm looking at the pentagon up there. So now I have that this is half times the perimeter times the height. Now, that height, I said, had a special name, right? That was the apothem. And that has the letter A, the symbol A. So this is equal to half times P times A. And that is normally what we use. Okay? You can derive it any which way. Okay, so that's the area of it. Okay. So the area of a regular polygon is half times P times A. P is the perimeter, and P is the number of sides times the side length, which we already talked about. Okay? All right. So how do we find the area of a regular polygon? You have to draw one triangle from the center to 2 consecutive vertices. So you don't have to draw like all 7 or all 5 of those. Okay, just draw one triangle. Draw the apothem. Sometimes we have to use SOHCAHTOA to find the missing measures. We love doing that though. We have to find the perimeter if it's not given. And we eventually find the area. All right, so let's do one. I love this stuff. Okay, so we're going to do this one. We have a regular pentagon with a perimeter of 40 meters. So just like it says for the first one, it says to draw one triangle from the center to consecutive vertices here. See? Consecutive vertices. All you have to do is draw one triangle. I like to do it at the bottom because it's right side up. You can be masochistic and draw like that triangle, whatever you like, okay? Now, if the perimeter is 40, how big is each of the sides? 8, right? So it's 8, 8, 8, 8, 8 here. That means each one of these is what? 4. You always have to do that. It's the same thing every single time, okay? You've got the length of a side, and then the triangle has a base that's half that side, okay? Now, I need to find the missing sides here because I need the apothem, and I'm not given the apothem, but can I find the apothem? Yes, I can find the apothem. For that, I need a little bit of trig. For trig, I need to know the angle. Well, how do I find the angle? Central angle is equal to 360 divided by the number of sides, which is 5. So the central angle is 72. That means this entire thing here is 72. Each one then is 36. That tiny little one is 36. Okay? Now, can I find the missing side, the apothem? This is A, right? If I need A, I have my angle 36. This is the adjacent side. This is the opposite side. What ratio am I going to use? Tangent. Tangent of 36 is equal to A over 4. A is equal to 4 times tangent. No. It's 4 over A. That means what's A? If this is over 1, then A is equal to 4 over tangent of 36. All right? 4 over tangent of 36. Because, remember, we divide like this, we multiply like this, 4 times 1, divided by that. The A then is 5.5. Okay? And I'm given that my perimeter is 40, so now I can find the area of the entire shape. It's half times P times A, which is half times the perimeter 40 times the apothem 5.5. 20 times 5.5 turns out is 110 square centimeters. Okay? So this is how we do it every single time. It does take long, but it's so much fun. It'll take less and less time each time because, like, you know, like right now I'm explaining to you guys how to do it and so on and so forth. Okay. Each side length is 10 and we've got a hexagon. Okay, so we're going to use all this information. All right. Each of these is 10. So let's find the perimeter. It's 6 times 10. 60 inches. Now, I have to draw the angle. Okay, I draw one central angle. How much is the central angle? Right. 360 over 6 is 60. Now, when I draw my apothem here, how much is each of these angles? 30 and 30. Now, what do I have? What kind of triangle do I have? 30, 60, 90. They're going to be everywhere. Okay? Those are everywhere. So look, now I've got a 30, 60, 90. This is a 30, this is a 60, this is a 90. So remember, it's x, and this one is what? X root 3, and this one? 2x, right? All right. So if this entire side is 10, how much is the base of the triangle? 5. That means this is 5 root 3. So my A is 5 root 3. Am I done? Do I have everything now? I sure do. So it's half times P times A. Half times 60 times 5 root 3. So this is 150 root 3 square inches. Okay? Which means it's 259.8 inches squared. All right? You can use Sokotowa, but, you know, a little piece of sisterly advice. Let's not forget about the special right triangles. They're going to be with you for the rest of your life. Yeah.
Should we always give it to you, like,
It'll specify. But if it says exact form, this is what I'm struggling with on the test right now. If it says exact form, please give it to me in exact form. Okay? All right. Look at how fun this one looks. Oh, my goodness. Oh, my goodness. All right. So, shaded region. How are we going to do this? We're going to do the area of the outside minus the area of the unshaded. Right? Which means we need to find the area that we need is the area of the circle minus the area of the triangle. Okay? Can we find the area of the circle? That's easy because we have the radius given and it's just pi r squared. What we need though is to find the area of that triangle. Now that is an equilateral triangle. Okay? So, We find it using what we were doing up there. We draw sides from the center to 2 consecutive vertices. And now, how big is the central angle? Well, it's 360 divided by 3 this time, 120 degrees. And if I draw my apothem, how much is each of these angles? 60 and 60, which again, 60, 30, 30, 60, 90 triangle, we love those, right? So now, is the 4 the short leg, the long leg, or the hypotenuse? It's the hypotenuse. And if the hypotenuse is twice the short leg, then how big is the short leg? 2. That means how big is this? That's 2 root 3. Which means how big is the side of the triangle? 4 root 3. Okay? And how big is the apothem? So my side is 4 root 3. And because 2 root 3 is for half the triangle, this is 2 root 3, and the side of the big triangle is 4 root 3. If the side is 4 root 3, then the perimeter is 3 times 4 root 3, which is 12 root 3. The perimeter of the triangle, this big triangle, is 3 times 4 root 3. And we had said that the apothem was 2. So now let's fill all the stuff in. So the area that I want is the area of the circle, which is pi times 4 squared, minus the area of the triangle, which is half, times 12 root 3, times 2. So the area is 16 pi minus 12 root 3. If I want the answer in exact form, this is the exact form. Okay? And when we plug it into the calculator, what do we get? Mm-hmm. 29.5 meters squared. Yes? Woohoo. All right. Look at this one. I just love these. Love, 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 love these. All right, look at this one. What do we need? Our area is going to be the area of a square, not a rectangle, but a square, minus the area of a circle. Okay? Always do this. Okay? Divide and conquer. Because if you've got a huge problem, then it's a mess. But if you can divide it into little increments, little tiny modules, then you can do this. Okay? Now, the area of the square and the area of the circle. Well, we don't have information for anything, it seems, for this one, right? Well, let's focus on the square first. In order to be able to find the area of the square, I need to know how much a side of the square is, which right now I don't have anything given, okay? But I can do this, and that's another 8, okay? And now, how big is this? What do we have here? Right, that's a radius, so we're killing like a lot of birds in one stone in this problem, okay? Now, this is a right angle, and how big is this? Okay, so the central angle here is 360 divided by 4, which is equal to 90. That means this is 45 and this is 45. Well, if that's 45, then this is 45. Okay? Now I have a 45, 45, 90, right? And this is x, x, x root 2. What's the length that I'm given here? Is it one of the legs or the hypotenuse? It's the hypotenuse. I'm given that my x root 2 is equal to 8. So my x is 8 over root 2, which is 8 root 2 over 2, which is 4 root 2. So now, check this out. This is 4 root 2. This is 4 root 2. I did just kill 2 birds with 1 stone. Because what is this vertical side? That's the radius, right? So now I just found out that my radius is 4 root 2. And how big is the side of my square? 8 root 2.
Oh, yeah.
So the perimeter of the square is 4 times 8 root 2. And that's equal to 32 root 2. Okay, do I need apothem for the area? No, right? Because this is a square, I could just do that times 8 root 2 squared. So now, let's do area. My area is the area of the square, which is 32. Oh, why did I even find perimeter? Did I need perimeter? No. It's 8 root 2 squared minus the area of the circle, pi times 4 root 2 squared. Lots of squares here. So this is 64 times 2 minus pi times 16 times 2. So this is 128 minus 32 pi. That's the answer in exact form. And if you plug it in decimal form, it's 27.5 units squared.
Do you want us to change it?
No, not really. All right. Okay, how are we going to do this one? Area of what minus what? Area of the circle minus the triangle. Okay? 30, 60, 90 triangle. Who doesn't love 30, 60, 90 triangles? Which side am I given? Short leg, long leg, hypotenuse? Short leg. That means the long leg is how big? 5 root 3. And how big is the hypotenuse? 10. How do you know which one's which? Yes. The diameter, remember? The diameter is 180 degrees for the central angle. That means it faces a 90-degree inscribed angle. See? It all blends together. Okay? So now, do I need to find apothem for the area of a triangle? Right triangles are the best triangles because you can find the area very quickly. Base times height is each of the legs. Okay. So, do I have a radius here?
Yeah.
How big is the radius? 5. So the area here is pi times the radius, 5 squared, minus half. Don't forget the half. Usually students are like they have such a rush doing this. They just, forget because they're so excited. Half times 5 times 5 root 3. Okay? So what is it in exact form? In exact form, it's 25 pi minus 25 root 3 over 2. This is it in exact form. It's okay that it's not one term. It's okay that you've got an addition or a subtraction. That's the answer in exact form, okay? And when you plug it into your calculator, what do you get? 56.9. Okay, my, look at this one. We're doing area of a circle minus area of a what? hexagon. Okay? All right. Do we know the radius for this one? 10. We'll just write that over here. Now, I need to find the area of the hexagon. So I do it just like I did all the other ones. I draw two sides here. Okay? Now, how much is the central angle? 360 over 6 is 60. So each of these are 30 and 30. And I've got a 90-degree angle there for the apothem. Now, 30, 60, 90, I love that, okay? I know what the radius was. The radius is 10, so that side is, oh no, that side is not 10, sorry. Right. The radius is 10, right? The radius of the circle is 10, so this is 10. Isn't that a radius of the circle? That is a radius of the circle. See, you have to think outside the box. Haha. Okay? Outside the circle. Or inside the circle. Outside the box, inside the circle. Okay? That's actually where this comes from, is because, you know, these are derived from having these inscribed in a circle. Okay, now, 30, 60, 90 triangle. Sometimes, well, not sometimes, all the time, it gets so scrunched inside these little diagrams. Okay, like I've actually made these bigger than they would be. So don't be afraid to take that triangle out, extract that triangle, write it, draw it here. Okay, make it bigger, but make sure you orient everything properly. This is the 10. Okay, which side is that? Is that the leg, or that's the hypotenuse. So how big is this side on the bottom? 5. And how big is this side here? 5 root 3. Out of these, this is the apothem, right? Okay. And how much is the side of the hexagon then? 10. Okay. S, which is the side of the hexagon, is 10. All right. That means the perimeter is how big? 10 times 6, which is 60. And we said that the apothem was 5 root 3. Okay. We're ready to plug this stuff in now. The area then is the area of the circle, which is pi times 10 squared. You gotta love that 10 squared, right? Minus half times the perimeter times the apothem. So this is 100 pi minus, how much is that in exact form? 150 root 3. Okay? And if you plug it into your calculator, what do you get? 54.4 I have here. And the units are squared. Okay, inches squared. All right. Area addition postulate, we've seen this before. Basically, the area is, you know, the sum of all the non-overlapping parts. All right, find the area of the shaded region here. Do we know how to find that? We sure do. Okay. What is this here? Area of the big rectangle minus the area of the little rectangle, right? Okay. So how big is how do we find the area of the big rectangle? Well, what are its dimensions? If it's 100 from here to here, to that I'm adding a 25 and another 25. So the entire side of the outside is how much? 150. And how about this? It's 25 here, 25 here, and how much is this part? 20. It's going to be 70. So this is going to be 70 times 50. 150. It's 25 here, 25 here, plus another 20 there. It's 25 here. Okay. 70 times 150 minus 100 times 20. And if you plug that in the calculator, how much do we get? We get 8,500. Okay? So these are the problems where, you know, like there'll be a word problem. There is a pool with a deck surrounding it. How much is the area of just the deck? That's how you would do it. Okay? Now, you've got an interesting little setup here. Okay, so basically you've got like a field, and you know, with this addition here, you have to find this area. Okay, this is it. This is now putting everything together. How many different shapes do you see here? We've got a rectangle here, right? What do we have here? A triangle. And what about these? Two semicircles, which together makes one circle. Okay? So, we're going to do the area of a circle plus the area of a rectangle plus the area of a triangle. Okay? All right. So let's see. For the area of the circle, what's the radius? 8. So it's pi times 8 squared. Plus, for the rectangle, it's what times what? 32 times 16. And the triangle, remember, has a half. It's half times what times what? Right. 32 times 15. Huh? Okay. And all together, this is
I got 1,153.
953.1. 953.1. Try it again. Okay. 0.1. Okay, look at this one. It's like a little manila envelope. Okay? Well, what are we going to do here? We're going to have to find the area of the rectangle and subtract from it the area of a what? A triangle. Right? Okay. 953.1. Okay. We're fine with the area of the rectangle, right? That's just 10 times 8. But the triangle, we need to find the area of a triangle, that triangle. Okay? Well, how are we going to do this? We need the height. And we have that this is 4.5. How do we find that height? Pythagorean theorem. So it's going to be 4.5 squared plus h squared is equal to 8 squared. All right, and go ahead and find h. I'll pause for a minute. Okay, so let me fix that equation. So this is 4. So 4 squared plus h squared is equal to 4.5 squared. And now we need to find what h is. And h is 2.06. Let's go to 2 decimal places. 2.06, so our answer is a little bit more accurate. So the total area is 10 times 8 minus half times 2.06 times 8 this time. And the total area is 71.76 inches squared. And there you have it. So this homework will be due next class.
Tuesday.
Yeah.